Most people are learning tech for a job market that doesn't exist. And I say this as someone who runs Sigmaschool. I've seen a lot of beginners. I've seen career switches. I've seen people go from knowing almost nothing to building real applications, real projects, and getting real opportunities. But I've also seen the other side. People spending months learning coding, watching tutorials, collecting certificates, and at the end of it, they still cannot build anything useful without someone holding their hand. And in 2026, that difference matters a lot more than before because AI changed the game. But I don't think it changed the game in a way that most people talk about it. Most people ask, will AI replace software developer? I think that question is way too shallow. The better question here is, what kind of software developer becomes more valuable because of AI? And that's the question that really matters to you. Because if you're trying to break into tech right now, you cannot learn the old way anymore. The old way was learn syntax, watch some tutorials, build some small projects, get a certificate, apply for junior developer jobs, and hope someone gives you a chance. That path is getting weaker. Not because coding is dead. Coding is not dead, but the value of basic coding has dropped because AI can now produce basic code very quickly. So if your only edge is, I know how to write basic code, your edge is shrinking fast. But if you can take AI, code, product thinking, and debugging and use all of that to build real working software, your value goes up. That's the gap that I want to talk about. It's called the builder's gap. The builder gap is the difference between someone who knows technical concepts and someone who can turn a messy problem into working software. Because from first principles, what is software? Software is not just code. Software is a system that takes an input, applies some logic, stores or changes data, and gives a useful output to the user. That's it. A user has a problem. The software helps them do something cheaper, better, faster, or more reliably. So if you learn coding but you don't know how to solve a user's problem, you are missing the point. One person knows what React is. Another person can build a working dashboard, connect it to a database, add login, deploy it, and explain how the businesses can use it. One person knows how to prompt ChatGPT. Another person can build an AI tool that takes customer inquiries, classifies them, drafts emails based on real information, and flags urgent cases for a human. One person will say, I finished the course, but another person says, here's what I built, here's the link, here's the problem it solves, here's how it works. The second person is going to be so much harder to ignore. And that's the kind of person that we're trying to train at Sigmaschool. Not someone who just collects certificates, not someone who just memorizes syntax, not someone who can just follow a tutorial and then freezes when the app breaks. We want to train builders, people who can think, people who can debug, people who can ship, people who can use AI without being completely dependent on it, because that is the real skill now. Let me explain why this matters from a first principles perspective. Before AI, a lot of the difficulty in programming was producing the code itself. You had to remember syntax, you had to search Stack Overflow, you had to figure out how to structure your files, you had to slowly write the logic. Now, AI can help with that. It can generate code, it can explain errors, it can suggest structure, it can write boilerplate code, it can help you understand unfamiliar code, and that's genuinely powerful. But it creates a new problem. Beginners can now produce code faster than they can understand it, and when you produce code that you do not understand, you feel productive, but you're not actually in control. The app works until it breaks, then you're stuck. You ask AI to fix it, it gives you more code, that code creates another issue, you paste it in again, now your app becomes even more confusing. After a while, you're not building anymore, you're just begging the AI to kind of understand and get what you want, and you're trying to get it to rescue a code base that you don't understand. And that's what I call the AI copy and paste trap. The AI copy and paste trap is when AI makes you move faster than your understanding, and that's very dangerous today because speed without understanding creates fragile developers. You can create demos, but you can't create reliable products. You can impress someone for 5 minutes, but you can't survive real work. Real work is extremely messy. Real work has unclear requirements, use bad data, users who don't know what they want, bugs that only happen sometimes, features that sound simple but touch 5 different parts of the system, a button that works for one user but fails for another, a database rule that blocks something, an API that returns something unexpected, a login issue that only happens on mobile. That's where real developers are needed. Not when a tutorial works, but when the tutorial ends. So if you're learning tech today, I think you need to learn like an AI native software builder. For me, that's 4 parts. First, understanding the problem. Second, building the system. Third, using AI as leverage. Fourth, shipping the proof. Let's start with the first one, understanding the problem. Most beginners skip this because they think coding starts with code, but actually good software starts before code. Good software starts with understanding the user. What is the user even trying to do? What is painful? What is slow? What is repetitive? What is expensive? What is confusing? What keeps on breaking? What decision do they need to make? What information do they need to see? And that's a first principles way to think about projects. A lot of beginners ask, what project should I build? Then they build the same things everyone else builds: a calculator, a to-do list app, a weather app, and a clone of a famous website. Those are amazing for practice, but if everything in your portfolio looks like a practice, companies will treat you like a student, and you don't want them to treat you like a student. A strong project starts from a real problem. For example, a sales team keeps losing leads because follow-ups are done manually and they may forget it. That's a real problem. So you build a simple lead tracker. A school wants to know which students are falling behind. That's a real problem. So you build a student progress dashboard. A recruiter has too many resumes to review. That's a real problem. So you build a resume screening system. A small business gets customer inquiries from WhatsApp, email, Telegram, Instagram, Facebook, and nobody knows what has been replied to. That's a real problem. So you build an inquiry management system. Do you see the difference here? Project is no longer just, I want to practice React. The project becomes, I'm solving a workflow problem. And that changes the way people see you work because nobody pays for code code in isolation. They pay for solved problems. Let's move on to the second part, which is building the system. And I want to be very clear here. If someone tells you that you don't need to learn coding because AI can code, I think that's very dangerous advice. You don't need to memorize everything. Sure, nobody does. But you do need fundamentals. You need to understand how the web works. You need to understand how front end works, how back end works, how databases work. You need to understand APIs, GitHub, authentication. You need to understand deployment, because every real app is basically a system. There is a user interface. The user clicks on something. The action triggers logic. The logic may talk to a database. The database stores or retrieves data. The app shows the result back to the user. Sometimes there's an external API. Sometimes there's authentication. Sometimes there are permissions. Sometimes there are errors. If you understand that flow, AI becomes extremely useful. But if you don't understand that flow, AI becomes a slot machine. You keep prompting it and hoping the next answer works. That's not engineering. That's gambling. So yes, absolutely use AI. Use it aggressively. I use it like crazy. Use it to move faster. Use it to explain errors. Use it to generate the first draft. Use it to review your code. Use it to help you with your thinking and new ideas. But do not outsource your brain. AI should make your thinking faster. It should not replace your thinking. Okay, so now the third part is to use AI as leverage. This is where the opportunity is huge. Most people use AI tools like Copilot. They use it to write captions, to summarize articles, to rewrite emails, to generate ideas, maybe improve their resume. That's useful, but that alone does not make you highly valuable. The real opportunity is learning how to put AI into a software. Let's say you want to build a resume reviewer. The basic simple is easy. Upload a resume, send it to AI, get feedback. That's a demo, but a real product goes much deeper. The user uploads a resume, the system extracts the text, the user pastes a job description, the AI compares the resume to the job, it identifies missing skills, it rewrites bullet points, it scores the match, it saves different versions, it tracks improvement, it gives suggestions that are specific to the role. Now, you're not just using AI, you're building a workflow around AI. That's where the value is for AI apps, because from first principles, the model is only one part of the problem. The model takes an input and it gives an output, but the value comes from what you wrap around it. What input do you collect? How do you clean it? What context do you provide? What output do you show? How does the user react to it? What should be saved? What should be reviewed by a human? What happens when the AI is wrong? That's product and engineering together. Okay, so let's talk about the fourth part, which is the ship proof. And this is where most learners lose. They say that they've built something, but there's no live deployed link, no GitHub repo, no walkthrough, no explanation, no user flow, nothing, right? That's not enough anymore. If no one can open it, it almost does not exist. Your work needs to be visible. A strong portfolio should answer 4 questions quickly. What problem did you solve? Who was it for? How does it work? And what did you build? That's it. A good project should have a live demo, a GitHub repo, a short walkthrough video, screenshots, and a simple explanation of what you have learned. That builds trust, because you're not just claiming that you know how to code. You're showing the real evidence. You're showing that you understand. You're showing mastery. And evidence always beats claims. This is something that I repeat a lot. Don't tell people you're hardworking. Just show the work. Don't tell people you're passionate. Just ship something. Don't tell people you're learning AI. Just build something with AI inside of it. The market does not reward intention. They reward proof. And this is why I think tech education has to change. A lot of education today is built for the pre-AI era. Lecture first, theory first, syntax first, slowly build it up for months. Then maybe at the end, you build a project. I think that model is incomplete now. We got to flip it, right? You still need to understand the fundamentals, but you need to learn them through building, because the real skill is not remembering functions. It's not about remembering information. The real skill is knowing what to do when you're stuck. How do you break down a problem? How do you ask better questions? How do you problem solve? How do you debug? How do you read code you didn't write? How do you use AI without trusting it blindly? That's what matters. And I want to be honest, because this path is not the easy path. If you want a shortcut where you passively watch videos and magically become job ready, this is not that. You will get confused. Your app is going to break, like it or not. You will hit errors. You will feel stupid sometimes. That's completely normal. That's not a sign that you're not meant for tech. That is the work. The people who win are not the people who avoid confusion. They're the people who learn how to move through it. Build, break, debug, ship, explain, and repeat. That loop is more important than any single programming language, because the tools are going to change. Frameworks will change. AI models will change. But the ability to turn messy problem into a working system will always stay valuable. That's the skill. So if you're trying to break into tech right now, here's my honest advice. Stop asking, what should I learn next? Ask, what can I build next? Pick one real problem, build the smallest useful version of it, use AI to move faster, force yourself to understand the important parts, deploy it, record a walkthrough, put it on GitHub, explain the problem, the solution, and what you learned, then do it again. And that is how it becomes very hard to ignore you in the job market. Not by collecting more content, not by waiting until you feel ready, not by hiding behind another certificate. It's by building proof. The future of tech does not belong to people who can only write code. It belongs to people who can use code, AI, and product thinking to create real outcomes for users. That's what I mean by an AI native software builder. And that's the kind of person we're trying to train at Sigmaschool. If this gave you a clearer way to think about learning tech in 2026, save this video and send it to someone who is still learning coding but has not shipped anything real yet.